we're going to start looking at straight lines in Cartesian coordinates. So let's draw our Cartesian plane. Here we have the x-axis as per usual. Here's the y-axis, and if we have a straight line, such as this. Sorry about the dots everywhere. Let's rub these out. We want to be able to write an equation to represent this line, and as I'm sure you've all seen at GCSE, we can write the equation as y is equal to mx plus c. The names of m and c are not particularly important. It's what they represent. So m is the gradient and c is the y-intercept. X and y are variables, so x takes values, real values, all the way from way over here to way up here, so from negative infinity to positive infinity. X takes all those different values at different times, and y is the same. So they just range, and picking different values for x, we can find the corresponding y, and then we plot them, and that's where we get a straight line. Anyway, so this red point here is the y-intercept, c, and if we want to find the gradient, one way to do this is to pick a point. So we say we take this point and we call this point x1, y1. So here x and y are not variables. x1 is this particular value here, and y1 is this particular value. Then if we take any point further along the line, so we could take a point here, draw a little triangle, or we could take a point here and do the same thing, or we could even take a point down here. Each of these have coordinates x and y, and this line, for example, this is y, supposed to be a minus sign, terrible handwriting. This is y minus y1. Okay, you can see because this total height here is y, but this little height here is y1. So if we want the length of this line, that's y minus y1, and this is x minus x1. The same corresponds from down here, even though this is terribly drawn. But anyway, if we take the height y here, which is minus whatever, and subtract y1, again we get the length of this line. Okay, so we can then calculate the gradient as y minus y1 over x minus x1. As I say, where y1 and x1 are given points and x and y are variables. Okay, so this doesn't actually explicitly give us the gradient, but it allows us to write the equation of a line in terms of the gradient, not in terms of the y-intercept. So we rearrange this, write y minus y1 is equal to m x minus x1, and this gives us a way of representing a straight line without knowing the y-intercept. Okay, so this is a unique representation of the straight line, and we need 2 points. We also need a second point, so then we'll have a value for x and y, and x1 and y1, and then we can plug that in to find m. Anyway, There's one more form the specification wants you to be familiar with the equation of a straight line, and that is in the form ax plus by plus c is equal to 0. Note that this c is not the same as the y-intercept c, just so I happen to call it, it's just some constant, so a, b and c are constants, x and y variables again. And we can rearrange this to see that it is equivalent to this form, okay? So I'm going to subtract ax and c from both sides, get by is equal to minus ax minus c, divide by b gives y ax over b minus c over b. Of course here I've assumed that b is non-zero, but that's a safe assumption to make, because if b is 0 then we've got no y coordinate, and then we haven't really defined a straight line there. The only one we could do is the line maybe, you know, x equals 5, that's just a straight line up. That doesn't really take this form here. So anyway, x equals 5 is just an example. X is equal to some constant, of course, gives us a straight line, but on a line like that the gradient's not defined, lots of things aren't, so that's a special case. So here we're assuming b is not equal to 0, and let's just write this slightly differently, is equal to minus a b times x minus c over b. So here we have a constant in front of the x and a constant at the end. So this is our intercept, this is our gradient. So as you can see, if you get a line, if you get an equation in the form ax plus by plus c, where a, b and c are constants, you know this represents a straight line now, because we've rearranged this into a more conventional straight form. And the same if you're given an equation like this. So let's just do an example of each. So let's say y is equal to 3x plus 5 over 2, and we know that this passes through the point x equals 1, and then we can calculate the y, so we know y is equal to 3 times 1 plus 5 over 2 is equal to 3 plus 5 over 2 is equal to 6 over 2 plus 5 over 2 is equal to 11 over 2. So it passes through this point. So we've got one form here, and I want to find this in the other two forms. So first of all, I want to find it in the form y minus y1 is equal to m x minus x1. So we know it passes through 11 over 2. Y minus 11 over 2 is equal to 3, our gradient, x minus 1. This gives us the y. So that's one form that we're looking for. We can now use this to find in the other form. So we've got y minus 11 over 2 is equal to 3x minus 3, multiplied by 2, we get 2y minus 11 is equal to 6x minus 6. So now we get 2y minus 6x, plus, add 6 to both sides, minus 5 is equal to 0, and as you can see this is the form here. So hopefully you can see now how all these forms of a straight line are equivalent, and we're going to use these in future videos to do some work with straight lines and find some various lines that we want with certain properties and stuff like that. You should be familiar with a lot of this from GCSE, so I'm hoping a lot of this will be a recap. If you've got any questions, please be sure to let me know in the comments. This is the start of a new series, so it's still part of the A-level series, so if you haven't seen any of the videos on that, be sure to check that out. It's the start on straight lines, so look forward to more videos on that in the future, and I hope to see you in the next one.